Hello everyone, so in this video we will be discussing the mean and the variance under the random variable distribution. So first let's discuss what is the mean and or how we can get the mean and the formula of the mean in random variable distribution. Actually this is just related to what we have discussed before last time, which is the mean and the variance. It's just that it just applies or it has a different annotation or denotation of the formula. However, the way or the process of how we get the answer or the mean is still the same. So basically, the mean of a random variable can be interpreted as the mean of the population or distribution whose observations are all the values of x that are generated by repeating the experiment over and over again, indefinitely. So here, it is also called mathematical expectation or expected value. So when you are asked to solve for the expected value of such a problem, that means that you have to solve for the mean. Okay, so it can be computed using the formula um, mu, this one, or that is equivalent to E times X. So as we know from the previous discussions for the first exam discussion, this is the denotation of the mean. So that is said to be equivalent to the summation of I is equal to 1 to the value of n, which is the summation of x sub I times f of x sub I. So f of x sub I here is practically the probability of our x sub I. Okay, they are just the same. And x sub I here is just the value of our x. So later on, we'll try to solve some example related to this one. So if x is a discrete random variable with a probability distribution given by p of x is equivalent to x, where x is equivalent to x sub 1, x sub 2, and so on, the mean of the random variable g of x is said to be equivalent to u of g of x, which is equivalent still to the summation of I is equal to 1 to n, which is the summation of g of x sub I times probability of our x sub I. And again, this is the formula in getting the discrete random variable for mean of our problem. This one is the general formula for the computation of the expected value. And this one is the mean or the formula for the mean if it is a joint probability. So if x and y are discrete random variables with the joint probabilities given by f of x sub x and y, or the probability of xy, where x is equivalent to x sub 1, x sub 2, and so on, and y is equivalent to y sub 1, y sub 2, and so on. The mean of the random variable is g of xy is said to be equivalent to summation of the g of xi yi times the probability of our x sub I and yi. Okay, so let's try to solve some example. We have here, let x be a random variable with the following probability distribution. Find the mean of x. So from the problem, it just state here that find the random variable. It does not state that we have to find the joint probability. So we'll be using the general formula of our mean, which is we have g of x is equivalent to e of g of x, or that is equivalent to the summation from I is equal to 1 to n of g of x sub I times f of x sub I. So from here, we have the values of our x. So these are our x sub I, x sub 2, x sub 1, x sub 2, x sub 3, and x sub 4. So from that, we can denote that our summation is from, or this one, our mean is from I is equal to 0 to 3, since this is our denotation for the x sub 1, x sub 2, x sub 3, and x sub 4. Okay, so it starts with 0 and ends with 3. Okay, so from that, that is our g of x sub I. And again, f here is just the probability of our x sub I. So we have here 0 is our g of x sub I. This is actually the value for our x sub I. So that is multiplied by our f of x sub I, or the probability, which is this one. So we have 8 over 27 plus, since this is just a summation, so you just have to add them together. So we have 1 times 4 over 9 plus we have 2 times 2 over 9 plus we have 3 over, I'm sorry, that's 3 times 1 over 27. Now, if you try to calculate that one, that is practically equivalent to 1. So, meaning to say, our mean for this problem is just equivalent to 1. Okay, so we have here another example. For the joint probability distribution shown below, find the expected value of g of xy is equivalent to xy. Also find our mean of x and the mean of our y. So from here, we have here the table, and it shows here the data that we can use for the joint probability distribution in order for us to find the mean. So we have here the values of the x. In horizontal, these are the values for the y. So this is just basically a coordinate for the x and the y. So first, again, we have to find the expected value, or the mean value of our g of xy. And since this is again a joint probability distribution, we'll be using the formula for the mean under joint probability distribution, which is, we have g of xy is equivalent to e of g of x and y. That is equivalent to the summation of our x from 0 to 2, and the summation of our y from 0 to 2 as well, since we have 0 to 2 datas here. That is g of x y times f of x and y. So this being said, we have to multiply the values of our x and the y, and we have to multiply that to the probability of their joint distribution. So first we have here, that is equivalent to, if our x and y are 0, so we have 0 times 0, the probability is f times 0 over and 0 as well. So we also have plus, if our x is 0 and our y is 1, we have our probability is f of 0 and 1, and we have 0 and 2 times the probability of 0 and 2, plus we have now, if our y would become 1, or if our x would become 1, our y would become 0. So these are just the possible probability. So we have 1 and 0 as well. We also have, if our x would be 1 and our y would be 1, we have 1 times f of 1 and 1, plus we have, if our x would be 2, our y would be 0, we have f and 2, and 0. Now, plugging in the values for our f of 0, 0, we have 0 times this one, the probability, which is 3 over 28, plus 0 times 1. But as you can see, it is just a pattern. So 0 and 1, we have 6 over 28. However, this is pointless because since we have values of our 0, and anyway, 0 multiplied with any other value, that is still 0. So this is just 0, 0, 0, 0, and 0. So basically, what we have left is just 1 times 1 times f of, or the probability of 1 and 1. So we have 1 times 1, and the probability of our f with x is equal to 1 and y is equal to 1, which is this one. So we have 6 over 28. So basically, 1 times 1 is 1 times 6 over 28 is just equivalent to 6 over 28. So meaning to say the mean for the joint probability distribution x and y is equivalent to 6 over 28. Now, from the problem, we also need to find the mean of x and the mean of y. So we'll be solving that differently or separately with the data still under the, the shown table here. So in order for us to solving for mean of x, so again we will be using the formula. Again, since this is a separate value, this is not under joint probability because we are finding the mean for the x alone and the y alone. We'll be using the general formula of finding the mean, which is the summation from x is equivalent to 0 to 2, summation of x times the value of our g of x. So we have here, again, for this one, we have x, which is 0. That is multiplied by the value of our g of x. So for the g of x, we will be using the marginal distribution, which is the total value under x, which is 10 over 28, plus our x, which is 1, times the total value under 1, which is 15 over 28, plus our 2 times 3 over 28. So that gives us, should be 0, so that is 15 plus 6, that is 21 over 28. So this is now the mean for the x. Now let's also try to solve the mean under y. So the same formula, we have mean for y is equivalent to summation from y is equal to 0 to 2 of y times h of y. So basically, since we are looking for the y, we will be using this data here. So we have 0 as our first value, and our probability is 15 over 28, plus our 1 times 12 over 28, plus 2 times 1 over 28. So basically, add them together, you have 12 plus 2, so that is 14 over 28. So this is now the probability or the mean of our y. Okay, so the last example for this video is we have here, let x be a random variable with the following probability distribution. Find the standard deviation of the random variable g of x, which is equivalent to 2x plus 1 squared. So as you can see, as you can see from here, we have the random variable. So it says that we just have to use the general formula for getting the standard deviation. But in order for us to get the standard deviation, we need to solve for the variance. But before we can solve for the variance, we need to solve for the mean. So in that case, we have to solve first for the mean in order for us to solve for the variance, and then we can already solve for the standard deviation. So from here, we have the data for the value of our x, which is -3, 6, and 9. And we also have the probability of our x is equivalent to x, which is 1/6, 1/2, and 1/3. So we'll be using that one in order for us to solve for our mean. Okay, so we have here, um, again, let's solve first for our mean of the equation for the problem. So we have mean of our 2x plus 1 squared, or the g of x, which is equivalent to summation from x is equal to -3 to 9. So we have here 3 and 9. So we have 2x plus 1, which is the value for our g of x, since as we know, again, this is g of x, which is equivalent to the summation of our I is equal to 0 to n, and that is g of x times f of our x sub I. So we have our g of x, which is 2x plus 1 squared. Multiply that with our f of x. Okay, so first let's start with our x as equivalent to -3. So we have 2 times -3 plus 1, that is squared, times our f of x, or the probability that our x is equal to -3, that is 1/6, plus our, if our x is equivalent to 6, is 1 squared times 1/2, plus we have 2 times 9 plus 1 squared, that is times 1/3. So basically, our mean for the problem is equivalent to 209. If you try to calculate this one, this is equivalent to 209. Now, we already computed our mean. We can already compute for our variance. So for the variance, we'll just be using the um, general formula, which is sigma squared of g of x is equivalent to I is equal to 1 to n, that is g of x sub I minus mean of our g of x, that is squared, times f of x sub I. So since we already have our probability here, there's no need for us to create a separate table, just like we did from the previous example. So we have here variance squared of g, sorry, that's our g of x is 2x plus 1 squared. So we have 2x plus 1 squared is equivalent to the summation of g of xi minus mean, which is our g of x sub I, which is 2 times -3 plus 1, sorry, plus 1, that is squared, subtracted by, so we'll have this, that is subtracted by our mean, which is 209, times our probability, which is 1/6, plus another, we have 2 times 6 plus 1 squared minus our mean, which is 209, this is again in squared. So sorry, this should be squared. This one as well should be squared times 1/2. The same process with the last one. We have 2 times 9 plus 1 squared minus our mean, which is 209. That is squared since that is variance, times our probability for 9, which is 1/3. So that gives us a value 14,144. So that is already our variance for the function 2x plus 1 squared. And as we know from the discussions that we have for the first exam topic, in order for us to get the standard deviation, we have to find, or we have to square root the variance. So sigma, or the standard deviation, is equivalent to the square root of our variance. So since our variance is equivalent to 14,144, so meaning to say we have to square root that. So that gives us 118.93. Okay, so this is now our standard deviation. You have to remember, standard deviation is just like a variance. The symbol is just like the variance, but without the squared sign. Okay, so that's it for this video. Thank you, everyone.